In this video, I will walk you through free response question number 3 from the 2001 AP Calculus exam. This is an accumulation problem where we are given an acceleration graph which we will use to answer questions about velocity. A car is traveling on a straight road with velocity 55 feet per second at time t equals 0. For the time interval from 0 to 18 seconds, the car's acceleration a of t in feet per second squared is the piecewise linear function defined by the graph above. Part A. Is the velocity of the car increasing at t equals 2 seconds? Why or why not? For this question, they are asking us about velocity, but we are given a graph of acceleration. First semester, we learned that velocity will be increasing when acceleration is positive and decreasing when acceleration is negative. At time t equals 2, the acceleration is positive. Therefore, the velocity is increasing. The velocity is increasing at t equals 2 seconds because v prime at 2, which equals the acceleration at 2, is positive. Notice that I mention acceleration because that is the graph we are given. Part B. At what time in the interval between 0 and 18 seconds, other than t equals 0, is the velocity of the car 55 feet per second? Why? It looks like it's time to bust out the first fundamental theorem of calculus. F at b equals f at a plus the integral of f prime from a to b. Rewriting this in terms of velocity and acceleration, we have the velocity at b equals the velocity at a plus the integral of acceleration from a to b. In this context, v of b represents the end velocity and v of a represents the initial velocity. We are given in the setup of the problem that the initial velocity is 55 feet per second at time t equals 0. So let's write 55 for the initial velocity, and let's put 0 for the lower limit of integration. But if we are looking for the time when the velocity is 55 feet per second, that means we want the end velocity to also be 55 feet per second. So let's write 55 here as well. We just need to find the value of b that will make this statement true. Subtracting 55 from both sides of the equation, we get 0 equals the integral of acceleration from 0 to b. So again, we need to find the value of b that makes this true. The integral of acceleration from 0 to b will be the area between the curve and the x-axis from 0 to whatever b turns out to be. From 0 to 2, the area under the curve is this rectangle. This rectangle has an area of 30 because the base is 2 and the height is 15. Remember that area above the x-axis is considered positive, while area below the x-axis will be negative. So the integral from 0 to 2 is 30. The area of this triangle is 30. I'm doing 1/2 base times height. 1/2 4 times 15 is 30. So the total area under the curve between 0 and 6 will be 30 plus 30, which is 60. So that is the integral of acceleration from 0 to 6. We need to keep going until we get 0. The area of the next triangle is negative 30. It's negative because it is below the x-axis. Adding that on to our previous areas gives us a total of 30. So the integral from 0 to 10 of acceleration is 30. The next rectangle has an area of negative 30. Adding that on gives us a total area of 0. So the integral of acceleration from 0 to 12 is 0. 12 is the value we were looking for. The velocity of the car is 55 feet per second at t equals 12 seconds because v at 12 equals 55 plus the integral of acceleration from 0 to 12, which equals 55 plus 0, which equals 55 feet per second. Part C. On the time interval from 0 to 18, what is the car's absolute maximum velocity in feet per second, and at what time does it occur? Justify your answer. I'm seeing this keyword absolute maximum. That makes me think candidates test. Here is an integral defined function for the velocity at any time t. The velocity will equal the initial velocity plus the integral of acceleration from 0 to any time t. I'm putting x's as placeholders instead of t's because you need a different variable for the function when you do an integral defined function. So pay no attention to the x's. To make a candidates test, I will need to find the critical values of the velocity function. The critical values will occur when v prime is equal to 0. But v prime is acceleration. So we need to find where acceleration is equal to 0. Luckily, we have a graph of acceleration, so we can just take a look and see where it equals 0. Oh look, acceleration equals 0 here and here. T equals 6 and t equals 16. Our candidates for the possible times of the absolute maximum velocity will include not only the two critical values that we found, but also the endpoints, 0 and 18. Let's find the velocity at each one of these times and see which one gives the absolute maximum velocity. We are given that the velocity at t equals 0 is 55. So what about the velocity at t equals 6? That's going to be the initial velocity of 55 plus the integral of acceleration from 0 to 6. The integral of acceleration from 0 to 6 will be the area under the curve between 0 and 6. That's 30 plus 30, which is 60. That means the velocity will be 55 plus 60, which is 115. Similarly, the velocity at t equals 16 will be 55 plus the integral of acceleration from 0 to 16. The integral of acceleration from 0 to 16 will be the sum of all of these areas, positive and negative. The total is negative 45. That means the velocity at t equals 16 is 55 minus 45, which is 10. How about the velocity at time t equals 18? I'm sure you already know where this is headed. It's going to be 55 plus the integral of acceleration from 0 to 18. Let's check out the graph. For the integral of acceleration from 0 to 18, let's take the total area from 0 to 16 that we found on the last step, which was negative 45, and add the extra 15 for a total of negative 30. That means the velocity at t equals 18 will be 55 minus 30, which is 25. The car's absolute maximum velocity of 115 feet per second occurs at t equals 6 seconds. See candidates test. Part D. At what times in the interval from 0 to 18, if any, is the car's velocity equal to 0? Justify your answer. We really answered this question in Part C. Our candidates test shows the absolute maximum velocity, but it also shows the absolute minimum velocity of 10 feet per second at time t equals 16. So, since the minimum velocity is 10, then the car never reaches a velocity of 0. The car has a minimum velocity of 10 feet per second, which occurs at t equals 16 seconds. the car's velocity is never equal to 0. See candidate's test in Part C.